Maximize cloud efficiency with Doit, the trusted partner in multi-cloud management for thousands of companies worldwide. Visit doit.com. That's DOIT.com. Doit, your cloud simplified.
When it comes to security, it's not just about securing the software development lifecycle and hardening setup and configuration of your Kubernetes clusters, workloads, and related resources beforehand, but it is also about thinking about the runtime protection, protecting the workloads and clusters when they're out there live running in different environments against active threats. And that is equally important. And some pieces of that can sometimes be down prioritized or even neglected. And today in the Kubernetes Unpacked podcast episode, myself and Michael are happy to be joined by Nigel Douglas to chat about all things security in Kubernetes, both beforehand and while it's live up and running in the different environments. Why this is important, and maybe we can get some secret knowledge, no joking, not that secret, about the best practices, tools, tips, and tricks that our listeners and ourselves can use to strengthen the security of our Kubernetes clusters and respective workloads. So welcome, Nigel. Thank you for joining us today. How are you doing?
Not doing too bad. It's actually the first sunny day we've had in a while. So yeah, It's a great day for that.
It's a great opportunity to start the day with some sun and Kubernetes Unpacked podcast.
Exactly.
Security. It's a tough topic that we were just discussing a bit before we started recording this episode, that we could when it comes to security, we could talk about it for hours and hours and hours. So we'll see which areas we can manage to scope on. But I would maybe like to start the conversation by asking you, Nigel, we have been talking in the community for some time that when it comes to Kubernetes, security has been down prioritized for quite some time. And that's why we have seen, for example, hundreds of thousands of clusters that had their API servers publicly exposed, that you could just get that statistics from the different scanning tools. So what is your take on that? Do you feel like it's getting better, or do you feel like that's true and we have been kind of neglecting it for a long time? Are we on the right path now, or we're still there?
I think there's two ways of looking at the problem. I agree that we've, to some extent, downplayed security in Kubernetes. The first place to look at is the role of the people in operations themselves. You hear the recurring thought process that, look, I'm an operations person. My goal is getting that piece of code into production and running, and I'll do it at all costs. But if that requires, doing an insecure configuration to allow that to happen, then I'll make that happen. And there are a bunch of examples. You could be using public images from public repositories that you don't necessarily need to. You could actually pull that into a private repository and just better ensure that it's secure. But things like excessive privileges, turning something on security context and privilege set to true when you didn't need to give it privileges. So these are recurring things we see, is that organizations are ignoring best practices because it's just operationally quicker and more efficient to do that. You get over the line quicker. The other side, I think, is more from an industry perspective, is that some software vendors are saying you need to shift left. You need to focus on securing the build process and making sure that everything's secure before you bring it to production. And then they downplay that whole topic of runtime security, what goes in actually is running in production within Kubernetes. So that's also a problem. So it's not a case of, you shift left and you ignore what's going on in production. It's a case of you shield right and you, of course, still enforce those best practices from a shift left. And I think Falco's definitely plays into that part of shield right, but we can definitely talk about how it plays its own part in the shift left perspective.
I feel like Kubernetes security sometimes remind me of the days of just give admin rights and we'll take it away later. We'll remember. Don't worry. It's one of those things where we say, yeah, we're going to do it, and then we don't do it. I also wonder if it comes down to, even though, and we're going to get into this, but general security as a whole is what we're doing in Kubernetes, but it's kind of looked at or implemented or thought about it a little bit differently. When you look at standard cybersecurity, you essentially have two realms. You have network security or you have AppSec. Very rarely do you see both kind of happening at the same time, right? You either see companies that are real good with compliance, they have all their tools running Maybe they have outside pen testers coming in, et cetera, every 6 months doing audits, yada, yada. Or on the flip side, you have like very, very strong application security teams where every single type of test is running before, code gets compiled and put anywhere. In Kubernetes, though, it's kind of doing both at the same time, just like naturally. Like it's not kind of set up like that because there's some rule, but it's just you're naturally working with software as you're working with Kubernetes as a whole. So it's kind of like jumbled together in a sense. And I often wonder if that's why, because there's no like separation of concern when it comes to Kubernetes security. It's kind of all jumbled up.
Absolutely. And it even comes down to the roles. I think there's still ambiguity or confusion around the operations roles. You hear people talk about DevOps, you hear of SecOps, then you start hearing DevSecOps. And there's a lot of confusion about, am I a developer? Am I a developer who also implements security practices? And if so, what is my scope? Where does the role end? It's a very good question. It's one that, people will keep defining DevSecOps differently. But in some cases, it's down to operational change probably creates that. So you go from, one day you have a monolithic application. You probably had certain security teams who handled traditional security infrastructure. So things like a firewall or your endpoint detection response tooling. And then overnight, they made a choice that we're going cloud native. We're going to start implementing containers, Kubernetes, all that good stuff. It's really hard to drop all your legacy tools and your legacy practices. And then suddenly, when we're talking about Kubernetes, like you say about those best practices, nearly everything's enforced via code. So, YAML becomes the single language that we're all uniformly speaking when it comes to Kubernetes. So it's a case where security teams can't just go to a legacy firewall and implement controls to control communications between workloads. They need to suddenly get into the Kubernetes environment. They need to implement YAML manifest to create network policy. Or if we're trying to configure constraints, well, we do that in the definition in YAML. So suddenly everything's done in YAML. And it gets to a point where you start to ask yourself, is now the security guy part of the DevOps cycle? And then they're very much a developer at this point because you're writing everything as code. And I think that's one of the problems. To go back to your previous point about some companies have just figured it out, I think it comes down to a few points. Like if you're a big financial institution, you have lots of budget, you can hire all the right people and you have the right tooling, and you don't really have those major concerns that get you over the line and do everything correctly. Like you say, you're doing all the right compliance checks, you've got the right people doing the auditing, all of that, even down to pen testers. But then for smaller organizations or where Kubernetes is only a small part of your day-to-day operations, it's very hard to say we're just going to hire a whole team of skilled people who are going to do all these skilled things suddenly overnight. And I think that's where security ends up getting forgotten within that system.
And I guess how good or how successful you will be with kind of the security piece when it comes to adopting Kubernetes also is tied very tightly into how your organization and how your R&D department, for example, is set up. Because from what I've seen personally throughout the years as well, that there are different situations that may happen here. You have, for example, a security guy, like you mentioned, or a girl, a security specialist in the organization, and then they are used to securing the traditional infrastructure, the traditional deployments. And then at some point, you decide to go cloud native, to go and adopt Kubernetes. And then it's not given that a security specialist can easily transition to understanding how security should be handled for containerization, for orchestration. And the same if you don't have a platform, like we are talking a lot about platform engineering, right? There are still many organizations who may not necessarily have the means or are not done building a platform, and they can't get that, all the security best practices implemented in an automatic manner. So a lot of that responsibility may fall onto the developers. So it's in addition to securing applications, they need to understand what images to choose that they can run their applications on top of, how to secure those containers, how to secure the configuration of those deployments of those apps to Kubernetes. And then suddenly developers need to know more around the security piece as well. And that becomes also complicated. So to me, it feels like the organizational piece here plays quite a significant role, even though we're getting those frameworks like we're going to touch upon, like the OWASP Top 10 and CIS, they give us those best practices, but you still need to implement them. There's no one that will come, no button you can click on, and then it's like, I fixed everything. It's now OWASP Top 10 compliant, for you.
And it's a very good point. Even though Kubernetes at this point, it's not, a brand new technology. I think we're celebrating about 10 years now at this point. Mm-hmm. But saying that, I don't think it's a mature technology, at least from an operational perspective. One of the things I would point out to from an operational maturity is the statistics they gather each year on how people are using the technology. Now, at Sysdig, we have a threat research report, a usage report we release each year, and it gives us a bunch of findings from real customer environments. And one of the findings, again, tying to the OWASP point, was the very basics, the things you're not supposed to do, the controls you're supposed to be enforcing. And I think it said something like last year, like say if we're comparing year over year, let's say 52% last year when we're talking about, it was specifically constraints, monitoring, for instance, CPU and memory constraints on a pod. They said 52% enforce constraints on pod. And it was something like 56% even monitor the constraints on pods. So when we think about that, and this is quite scary, we're saying just a tiny bit above half of all organizations that we pull this data from, they don't have any constraints and controls. So if you were to terminal shell into a container and run a crypto miner, you wouldn't be able to stop it from using excessive resources and abusing your cloud native environment. But the second one that's more scary is the basic thing of, hooking up Prometheus, doing metric scraping and monitoring CPU and memory, which you think are the golden signals, the very basic thing that you would do on day one. Nearly half aren't doing that either. So, I don't think we're at maturity when we're not doing the absolute basic things yet. And we're talking about the whole way down runtime security as well as not being fulfilled.
Well, I guess this is just a good life lesson for everybody. What you see on social media isn't real. So when you look at all the vendors saying Kubernetes is this and Kubernetes is that and mainstream and blah, blah, blah. True, but Nigel, to your point, it's still very much in its infancy. And I say that all the time as well, because, we even see all these different tools popping out just for that exact category. So performance optimization tools around cost, around resources. There are tools just doing that, open source, and people still aren't doing it. So it's a combination of so many different factors that go into the environment as a whole. And like we were kind of talking about in the beginning, people just want to get this thing up because that's friggin' complicated within itself. So once they get it up, it's like they're wiping the sweat off their forehead and they're like, all right, we're good to go. And it's like, no, you're not even close. And especially when it comes to the security pieces. So as we're kind of starting off, let's say we're at day zero, we're planning, we're writing architecture diagrams, we're thinking about where we're going to deploy, we're thinking about how we're going to deploy, all these, planning phases. What are, ultimately the best places to start? I mean, for me, I always tell people go CIS. If you open up the report and it's over 200 pages, don't worry. There's a lot of tools that implement CIS benchmarks inside of them, so you don't have to read the whole report. But the reports are interesting because it gives you the description, it gives you the rationale, and it actually gives you the fix for it. So it's not just a paper report. It actually is actionable information, which is why I like CIS. And then we have NVD, which is really just you're more or less scanning against a database. The NIST database, I know, Nigel, you mentioned this before. I always mess up the pronunciation. MITRE? Is that what it is?
Oh, yeah, MITRE ATT&CK.
I say Mitcher sometimes. I just spell it out sometimes because I have no idea. MITRE, now I know.
I'm calling it Mitre, but I guess that's totally wrong. It is the Norwegian way to pronounce it, but that was wrong.
Yeah. Well, as we said in the beginning of the podcast, you want a career where letters confuse you. This is the career for you.
Yeah, even the acronym is MITRE. It's attack, tactics, techniques, and common knowledge, I think, is the CK. But, I
already forgot.
Like they forced it to make the word attack with a at symbol as the A. So, yeah, they made it confusing deliberately. It's a very good point. To what you said earlier, I think the CIS is the best place to start for Kubernetes, mainly for a few reasons. I think there's kind of most of the vendors uniformly adopted it into their enterprise technologies. So The one I'm most familiar with from an open source perspective is Kubebench. I think Aqua Security maintained that project. So yeah, you just run like a single line command or something simple like that, and you get this lovely report that tells you kubelet is set with whatever configuration, like anonymous, auth set to true or something like this. And then it gives you a nice little description beside it saying you should change anonymous auth set to false. And then suddenly when you rerun the test, it'll show up as a green tick saying you've done it correctly. That's a great place for holistically securing the environment because it just looks at all of the possible insecure configurations. I think when we compare that to, say, OWASP T10 for Kubernetes, that's more like, I think what's nice about it is they try to provide guidance based on industry data where possible. So for instance, they don't just pull, advice out of thin air. They'll say something like, from all the environments we've looked at, from the threats that we've seen in the ecosystem, we'll tie how those attacks were achieved. So a lot of them are due to privilege escalation, lateral movement, this kind of stuff. So they'll say, well, how did they move laterally? How were they able to achieve that? And it all comes down to something like misconfigured permissions or something like that in a container. So then knowing that, they'll give some guidance. They'll say, these are the 3-4 controls that are most likely to lead to those kind of attacks. If you change file system to read-only on a pod definition file, then yeah, they've got read-only. They can't write over the existing files inside it. And that enforces that whole shift left through to production and standardizing everything. So there's so many frameworks to use. I think there's issues as well with some of these frameworks. Like MITRE ATT&CK is fantastic if you're looking at it from a traditional Linux enterprise perspective. I think where it gets weak with containers and Kubernetes is there's no definite Kubernetes framework. So there's no tying attack techniques and procedures to specific Kubernetes activity. There's one for containers, but even that's a bit, weak. It's not as expansive as one would expect. And then as for OWASP, they still say on their website that the T10 is very much a work in progress. And that goes back to our previous point of, people haven't reached the maturity where we're seeing enough people enforcing best practices to look at what are the things we need to add more controls on. So I think as the ecosystem evolves, as security becomes more of a paramount issue that we need to tackle, then I see these frameworks expanding, definitely.
Could this be the fact that we do not have a dedicated framework specifically for Kubernetes? Could the reason for that be because we haven't had enough attacks that exploit Kubernetes specific pieces? I mean, of course, I've read in the news that we see the increase of the attacks that are happening towards Kubernetes clusters. But like from your experience, Nigel, could this be the reason for why? Because we don't know what we don't know. So we basically don't know what can be exploited, even if we follow these frameworks, let's say like OWASP Top 10, and put all the actions in place and we are good to go. But we just don't know if it can be exploited in that case or not.
I think it could be a few factors. I think one of them is the variety of attacks. Like I say, a common attack vector that people keep aiming for, I see it more and more in Kubernetes, is things like crypto mining attacks, cryptojacking, where simply you hijack a workload, you shell into it, and you run a mining binary to exploit resources. And because Kubernetes is designed to be highly scalable and highly dynamic, it's a really easy target for that kind of attack. So you don't maybe see as many, the same variety of attacks that you would see on traditional enterprises. So maybe there's not as broad a scope of different attacks. And that comes back to the same thing I was saying earlier, which is enforcing things like constraints. If we went back to the basics, the threat landscape for Kubernetes is actually quite limited if we follow best practices. By default, it's actually quite insecure. Things like it's a flat network, so everything can freely talk. There's no security controls by default. So things like, permissions, everything's pretty much root. So yeah, like from that perspective, I think that's part of it. I think the other side is when we're looking at the people who maintain these frameworks, if I look at MITRE ATT&CK, I look at OWASP, they are communities. They've been around for a long time. They've got a huge group of researchers behind them, but they've been focused traditional application security. And I think that's probably the biggest part of the problem, is that if you say most of the applications running in the world that get targeted for attacks are monoliths, so you have like your Microsoft Office suite that you have on your desktop, that's probably where most of the research has gone into, even down to Windows endpoints. And when we think about Kubernetes and containers, it's all Linux. I don't know if that there's less research focus on that, or is it just that there's so many attacks on traditional monoliths and Windows endpoints that the focus is being taken away from Kubernetes because it only makes up, speculating, but a smaller percentage of the industry's applications. I don't know what your take is on that, but they're kind of some of the reasons I think there's been slower adoption for Kubernetes framework improvements.
It's interesting. I mean, Kristina, to your point, Nigel, to your point, when Kristina said it too, it kind of hit me and I was like, oh yeah, that actually makes sense. I don't think I ever thought about it like that. There's just not enough data. There's, Linux, various distros have been around for how long now? Active Directory has been around for how long now? Microsoft Office and all of these various applications, whatever you want to call them, tools, have been around for so long now that there is a lot of data on what it looks like to hit them in a real scenario. But I feel like a lot of the tests, like the security tests and stuff that I've seen hitting Kubernetes environments are just that. They're tests. They're not like real attacks in various environments. I'm not actually 100% sure I've really heard of a real big attack targeted at Kubernetes. I don't know if there are any kind of sitting around at the moment. I mean, I constantly hear about attacks in various environments, but I never hear it targeted Kubernetes. You always hear like it targeted a specific application, or a specific port was open, or something was public from a network perspective, but I never hear like this attacker went for Kubernetes specifically. So then again, it's almost like, like these tools, I mean, you look at the OWASP top 10, it hasn't been touched since 2022. And maybe it's just because we don't have the data, right? Like we can assume best practices, which is arguably what these frameworks are doing anyways, right? All of them, just for everything. It's always an assumption, more or less, until we get the, that happened, let's go ahead and throw that in. But other than that, it's very much an assumption because we don't have a lot of data.
Let's take a quick sponsor break. Maximize cloud efficiency with Doit, the trusted partner in multi-cloud management for thousands of companies worldwide. Doit's innovative tools, expert insights, and smart technology make optimization simple. Elevate your cloud strategy and simplify your cloud spend. Visit doit.com. That's DOIT.com. Doit, your cloud simplified. And now back to the show.
It's also a big problem as well with how the industry paints the picture of Kubernetes. I'll put an example here. I was working on an assignment for my master's degree. It was an advanced incident response module. So we were looking at common attacks that happen on a control plane, for, in this case, Kubernetes. So I focused on 2019. There was an attack against Kubernetes. It was Tesla's AWS infrastructure. So if you Google it, 2019 Tesla attack, it's stuff like AWS cloud attacked, So how it worked was, when we're talking about cloud native, yes, it's AWS because the Kubernetes is managed. So it was Elastic Kubernetes service. So it's a service within AWS. But fundamentally, it's Kubernetes. Everything about the attack cycle was Kubernetes. There was a lateral movement element where they'd hooked S3 buckets, but that's not the primary focus of the attack. So, the attack started, I don't know how they achieved the reconnaissance part of the attack where they discovered this, but basically, this Kubernetes dashboard that you can expose, and it's a big problem.
Oh, yeah. The scary problem it is. Yeah.
Exactly. So nearly everyone's familiar with it. On day one, they used as a way of monitoring their pods, checking logs, just really understanding if everything's healthy. So I think it goes back to the point about the developers got a bit tired of the whole process of forwarding it or something like this, but they did a few things. They were able to, and there's actually loads of articles on this topic, which goes to show how silly it really is. But they managed to, I think, load balance that's not the hard part. So they load balance the dashboard, but there's all sorts of ways that you can skip authentication on it. By choice, they put it in the configuration file to skip authentication. That way, they don't have to put in the kubeconfig file. They don't need to put any kind of secret. They just click a button that says skip.
Nice.
So the attacker was able to move in laterally through the Kubernetes dashboard into the Kubernetes environment. It's actually quite a sophisticated attack in the sense of then they were performing crypto mining. So again, there was no constraints or no restrictions on the pod. So they terminal shelled into it. They ran the crypto miner. Which miner, I don't know, is it Exim Rig or Nano Miner or one of those? But do you know the way normally you have to talk to a mining pool or port address if you're trying to do mining operation? So you can, of course, receive the rewards of your mining operation. Now, they knew that would probably be blocked by networking controls by Tesla because they're smart enough to do that. So they sent the request to a Cloudflare address, which the mining pool was behind Cloudflare, and that was seen as a legitimate endpoint to be talking to. So they were able to perform the operation for a while, but I guess what they were monitoring was, say, for instance, excessive resource usage or something like that, because within, I think it was 40 minutes or something like that, they were kicked out of the environment. So that was the end of the attack. So that's one of the things about Kubernetes is, first of all, they paint them as like cloud attacks as opposed to Kubernetes attacks, because Kubernetes is a fundamental component. It's a service of the cloud. But then the second part is they're not very long-lived attacks. You know, containers are ephemeral. They don't live very long. Some only live for like 2 minutes. So you're not going to be sitting in a pod for a very long time to achieve that attack. It's usually before being monitored. Again, if you have any form of Falco or detection engine to give you that kind of real-time analysis. But then the second side of it as well is that like organizations are painting as how can we better secure the cloud? And they're focusing so much on everyone log into the cloud tenant via MFA and all of the good stuff and comply with cloud security controls. And then no one talks about the dashboard, which was, you mentioned earlier, it's just an exposed component. That's probably the most interesting one I thought of. And that was, at this point now, that's about 6 years old. No, 4 years old. So yeah.
Yeah, that's crazy. Wow. I feel like that's security in a nutshell, right? It's like, just skip it. It's fine. We'll figure it out later.
In the beginning of the podcast episode, Michael, you mentioned like, the times when we used to give admin access and forget to remove it. I mean, I feel like part of that time still is here, you know? So it's not like just the memory of the past. It's still an issue.
100%.
Unfortunately.
If you're in IT long enough, we all kind of go like this in a circle, and we get right back to where we started in some way, shape, or form.
There's some joke I remember hearing years ago that if you stay long enough in the industry, you become the person you originally tried not to be, or something on those lines. That all those malpractices, if you stay long enough, you end up doing them yourself. So
Oh, that is funny. All right. So in the beginning, so your day zero pieces, really what people should be caring about are, the compliance frameworks that already exist. MITRE, CIS, NVD, etc. And then if you could find some best practices, lists things like the OWASP top 10 for Kubernetes, right? So stick to best practices, stick to just as close to compliance frameworks as possible. And then let's forward, however long it takes you to get that up. And now your Kubernetes environment is up, right? You thought about the best practices in the beginning, you implemented some CIS suggestions, you looked at some top 10 results, put it into your environment. Now what? So the first thing that comes to mind for me typically is policy enforcement. So like whether you're utilizing Open Policy Agent, whether you're, really like writing Go and you're just going head on with admission controllers and creating policies that way, regardless of how you're doing it. And Nigel, what are your thoughts there in terms of the overall places to start once the environment is up and operational?
Yeah, it's a good point. Like looking at Kubernetes long enough, I think a lot of these security monitoring controls should be done before production ever began. So, you'd have a staging environment. Yes, you do all your policy enforcement, but things like, even if you just turned on something like Falco and you monitored basic insecure behavior. So for instance, things like terminal challenge container, or, if you have the Kubernetes audit log plugin turned on, so there's this additional extension plugin for Falco, you can handle the Kubernetes audit logs themselves. So things like, for instance, service creation, pod deployment creation, being able to see when something's created, when it's deleted, what were the privileges, what were the settings on it as was created. It's really important because, to go back to our previous point about a pod was created and it didn't have any constraints for CPU or memory. Well, having that rule set up even in staging, and it's alerting you that something's created without constraints, that's a bit like the framework we were talking about earlier with CIS, is to say, these are insecure behaviors. Now I should go and create that policy. I think we can get so focused on creating policies and we think we've set them all up correctly And then we move to production, and then we start monitoring, and then we go, oh, wow, I forgot a lot of things, or I'm just not secured against the very basic things. So I think the whole monitoring experiment, reproducing threats, staging is actually the best place. So it's even before day zero. It's earlier on in the cycle. So Kubernetes is designed like that. You can create a small cluster, recreate what it is your basic look. So you have your red pods, your blue pods, they're in different network namespaces. Test out your policy enforcement, things like network policy and stuff, and try to make it as similar as well to production as you can, because when it eventually goes to production, those rules better work on day one. They also better not have, I think the big issue with a lot of monitoring tools is you're so proud that you've created all of these policies enforcement, you've created all these monitoring rules, and what you notice is a few things. It either has performance overhead because you're monitoring every single thing that is possible, and that's not a good way to go about it. It's just not realistically feasible in production. But then the other side of it is, if you put in really strong or stringent policies, like saying, for instance, anything that's got root permissions, shut it down. Well, then what happens if you kill, kube system or something, some like your network CNI, so like, for instance, I assume in all these cases, your network plugin, like your Calico or Cilium, it's going to need to have root permissions, and it's going to need to have all these excessive things. So you want to make sure everything's scoped correctly. You want to make sure your controls are tested before you move into production, because what you don't want to do is start breaking something when it's your actual customer delivered service.
So let me ask you this, because there are just so many different tools out there. There's so many different platforms. Is there like a cap of how many tools, how many implementations you should really be thinking about? Like, for example, Falco, for everybody that's listening, Falco is an open source tool from Sysdig. Shout out to Sysdig. Sysdig's been around for a long time, and definitely I feel like has been around since the beginning of Kubernetes security as a whole. So awesome products, awesome reports. But Falco, I'm looking at this now kind of for the first time here, but open source tool for, detecting threats essentially as a whole. So you have that type of tool. And then you have things like Kubescape, right? And then you have things like Kubebench. And there are all these different types of security tools, whether they're open source, whether they're enterprise. Even if they're standard monitoring and observability tools, right? You still get a lot of security out of the box with like Datadog, for example, lots of plugins that are available. But then engineers are looking and they're like, oh, there's like 10 tools here. I can't implement all of them. Is there like a particular cap of tools? Is there like start with one, see what it doesn't have, work your way up? Or is it like, is there one that they should just implement right out of the box and, kind of go from there? The whole question/statement from my end is, what's the biggest thing to a lot of people right now? The biggest question that I get is, what do I use? There's a lot of tools and there's a lot of practices and there's a lot of this and a lot of that. And like the biggest question that I get from people that are beginners in this space to people that are senior to principal level, like the same question is like, where do I start and what do I do? So I'm curious on your thoughts there as well. And Kristina, on your thoughts too, because I know you spend a lot of time in the Kubernetes security realm. It's like, what tool do you kind of use to get up and running? And then how do you figure out what other tools you need to use?
I think it goes back to even before I was working on Project Falco, I was working on Project Calico. It's a networking framework for Kubernetes. And we used to kind of reiterate the point over and over again is, what are you actually trying to do with Kubernetes? And that's how you answer the question, really. So there's examples like some people have Kubernetes as air gapped, and you have so many of almost identical replicas and everything's the same. And you might, in theory, be able to achieve all your points in just Calico, right? Like theoretically, right? Because you would say, I use it to lock down the workload communications. So they can't talk to things they're not permitted to talk to. So that complies with our regulatory framework. The second part of that is, what are your regulatory frameworks? So, if you're a merchant, you handle payments, you're probably going to comply with, say, PCI DSS. But even then, it's like there's rules around the amount of payment, conditions you're handling, and that incrementally decides what kind of controls you have to comply with. And also retention of information and this kind of stuff. So like if you're a small business and you don't handle a lot of payment details or none at all, but probably you don't comply with PCI or not at the same way a financial institution like a bank would. So, the number of tools that organization might need to implement is going to be far less than that large, JP Morgan Chase or something like that. I think the other side of it as well is, how much of it is getting exposed to the public. And then you're going to totally rethink, what am I monitoring, or what third-party services are communicating with my cluster. So, if I need to monitor, for instance, an identity platform like Okta or GitHub, because I'm bringing all the code in from my repo, then I'm going to start looking at different tools that are going to monitor different things throughout the application development lifecycle. But just starting off, if you don't know what it is you're trying to secure and you're just starting off, I think a great place is, you mentioned the policy framework. So OPA can be hard to enforce if you have no experience with it. I think that's a learning journey in itself. Network policy is a brilliant place, no matter which framework you choose, whether it's Cilium or Calico. I think a great place just to say, this pod, like, why would it need to talk to anything that it's not supposed to talk to? If a pod's supposed to, let's say you have a zone-based architecture in mind and you say front end should talk to, an intermediary workload and that talks to a back end, then the back end should never talk to public facing resources. So allow it only talk to pods with certain labels or something like that. Right. So there's a way of starting off with something like a network policy enforcement engine, use that for controlling network traffic, use Calico to monitor for unusual connection attempts. That's a great use case. And then kind of expand what it is you're trying to achieve from there. That's the way I would look at it. But I agree, sprawl is a big issue. And more vendors you hear and more projects are saying, avoid using 3 technologies when we'll do all 3 in one. And that's also not a solution, because it depends what your problem is that you're trying to solve.
Yeah, I mean, if I were to add on what you said, Nigel, I think it's also important to look into the standpoint, the situation you are in, because like one important thing that I have been following, and I have seen many companies following who care about open source and cloud native, is that typically when it comes to the tool choices, you may want to, if you have a good company policy that appreciates open source and it does not have a requirement that it must be an enterprise solution. Like personally, I always look at the tool in CNCF landscape, because I know those are governed. I know that license changes and that type of things will not come as a snowball on me and my company at some point, and we need to do a lot of rework. This gives me some sense of security, and I know that those are maintained and are cared by the community. And those are typically the tools that I would look into. Unless you have, for example, existing tools in the organization. Let's say you have a company that is already using SNCC and you have a company enterprise agreement with them. Then you don't need to go through the whole bureaucracy of getting a new tool or maybe paying more if you can get SNCC to cover some of those, for example, security scanning capabilities in place for you. And then the other piece here is, what kind of Kubernetes distribution are you running? One thing is running bare metal, for example, or just bootstrapping a Kubernetes cluster yourself. You need to think about so many more pieces compared to managed Kubernetes service. And often in a managed Kubernetes service offering, you get tools like policy enforcement available for you in a much easier way out of the box. Like I work a lot with AKS, Azure Kubernetes Service. I get Azure Policy as an add-on. All I need to do is just to set that property to true, and then it deploys that policy enforcement for me. If I want, I can turn on some of those templates that are basically a collection of the most important policies, like pod security policies. That is a set provided by the Kubernetes community of the most important rules to have in place, depending on if it's restricted type of policy or baseline or whatever. But I think I totally agree with what you said, Nigel. I would probably start with finding a set of templates or policy enforcement, because that would give me an overview of some of the best practices which are not in place. And that's where I would start. And then I would build upon that and look into fine tuning and looking into additional tools if I need that. But you also need to think about customers that may come asking if you're compliant with a specific framework, because I've seen that as well, where the customers came back once the Kubernetes-based solution was launched and they asked, do you have proof that it's compliant with OWASP Top 10, please? Because we will not use your services until it is. And it wasn't, because no one followed actually that OWASP Top 10 document or framework. And that kind of was a nasty situation to be sitting in when you are in production already and the customers deny to use it because you don't have proof that you're compliant. So thinking about that is also important in case you have such customers that may come asking.
Starting to wrap up here. If we can think about maybe 3 things right in the beginning for people to start to kind of do. My list, I think, would be starting from the bottom, network policies. Granted, you have a CNI that gives you the ability to implement network policies, right? Which most do, Cilium, Calico, and then you can also think about, the Q proxy replacement, go the eBPF route, etc. So a lot of capabilities out of the box there. So network policies, and then security-centric CNI, right? Again, Cilium, Calico have the ability to actually implement policies as well with that. And actually maybe 3 to 4, because now another one just popped in my head. We didn't really touch on it too much, but service mesh, right? Like even if you don't want to do service-to-service encryption, which unless you have a particular workload that can't, but even with like Istio or something like that, you have so many policies that you can utilize for routing traffic and such, right? And then I guess the 4th for me would be, start with one tool, right? Whether it's Kubescape, whether it's Falco, whether it's Kubebench, whether it's something, just to get some automation going and then figure out, okay, this tool doesn't have this, I need this. This tool doesn't have that, I need that. So Kristina, curious on your, 3 to 4, and then we'll pass it over to Nigel.
I would say that both network policies and having a security scanning tool are also on my list, because network policies are still very often neglected.
Yes.
And security scanning tool will give you that overview that I mentioned earlier. I think one more I would go for is probably RBAC. Regarding the access control, because it's very easy to just allow everyone to do everything they want in the cluster, and then people start exposing everything everywhere publicly that they shouldn't, and then you have this chaos and missing control piece. So thinking about how you could strengthen the access control and also the permissions, the authorization piece in the clusters as well, get that scoped. And maybe the 4th piece is exactly before you start deploying these workloads onto clusters, think about what do you want to expose? Because as we discussed earlier also with you, Nigel, it comes to publicly exposed services that will become that attack surface for those attackers to target. They would typically go for those services that are publicly exposed. So think about what is actually needed to be exposed. So Kubernetes dashboard shouldn't be on that list, in my humble opinion, among a few others. But I would probably start looking at those 4 at least. So what about you, Nigel?
Yeah, I think I'll be only repeating, I guess, for the most part, what you've already said, but certainly...
Then we are aligned.
No, we're definitely aligned. I think the one thing I would slightly add to that is RBAC, from what I've seen, at least I was giving a talk last year at Container Days in Hamburg about that OWASP T10 framework. And one of the things when I came out of it, and I genuinely asked people, because they were interested on like how you use RBAC, and everyone's saying, if it wasn't like an application getting delivered that had RBAC controls, like you see that they weren't doing it themselves. Like some people didn't really understand like the basics around service accounts, and the way it's abstracted, I think, confuses people. That's part of it. Like you have cluster roles, cluster role bindings, and everything's all kind of bound together. And I think that kind of scares people, but that's a very like fundamentally basic thing that goes before Kubernetes. It's legacy to Kubernetes. I think, networking certainly is like a huge deal. To go back to a previous point, if you're talking about multi-cluster networking, then suddenly you're going to have to really seriously talk about Istio, Linkerd, these kind of service mesh technologies. As you mentioned, like mutual TLS is a great use case, but some of them like stress testing, being able to ensure, like, for instance, only so much traffic is handled to the cluster, those kind of service mesh technologies, they have a lot of extensive use cases, topology mapping, all of this kind of cool stuff, which all ties into understanding your environment, especially if we're talking across clusters where it gets even more complex, then I think you'll end up implementing a service mesh. But if you're talking about like single clusters that are not connected to everything else, network policy is absolutely fine on its own. If you don't have a use case for it, don't implement an extra layer of complexity. I think the other part that I think is absolutely critical is the runtime monitoring technology. Now, I mean, there's a bunch of different projects you can use. There's Tracy, Tetragon, Falco. They're all kind of built on this idea of handling system call introspection, so handling events directly from in kernel, which is great because you see everything immediately in real time, well, at least within milliseconds, so less than a second. But I think a big part of that is just how you use these technologies. Falco's been around long enough to develop a rule maturity framework. So, on day one, when you use it, I think the big issue with any runtime tool, and I'm talking about even down to EDRs and stuff like that, is if it doesn't start alerting on something, if I don't understand how this thing's going to detect a threat, I'm less likely going to adopt it over time. Whereas with the network policy, it's quite clear. I just say, allow this to talk to this. And policy, at least from a Falco perspective, should be the same. So what Falco's done is it's just produced like a bunch of these predefined rules. Some of them are in sandbox rule lists, some are in like production ready lists. And the idea is you want to get less false positives. You want to be able to detect those insecure behaviors in line with those frameworks. So it has this kind of nice system of tagging the context. So you can tag in MITRE attack or the tactic technique ID or something like that to it. So when you are trying to comply with frameworks on day one, you should go, oh, cool, I see a lot of indicators of things related to lateral movement or defense evasion or something like that. I think that's a big point. So no matter what the tool is, to tie on to the Falco point is, it should kind of work on day one. And I think that's one of the problems we just haven't really addressed with some of the technologies. Like I want to say mission control has to be there, but why it becomes harder to implement is it's just not simple. Anything where you need to kind of do a boot camp on it, and you probably need to do a boot camp on any technology in Kubernetes, realistically.
Or many other technologies, not only Kubernetes.
Absolutely, but it just leads to this element of, if I didn't get it working there, or I started getting false positives, or something started breaking my environment, I'm just going to not use it.
Right.
Because operationally it just makes life easier, and it's also less overhead on my environment. So yeah, I think policy frameworks are great, but they need to be easy to implement on one.
One positive thing I'll just quickly add up to Falco, which I can share a bit of insider knowledge on, because I find it very cool that Falco community was in front of that. In the CNCF tag for environmental sustainability, we're currently collaborating with Falco to help the Falco project get overview, to get even more performant and more resource efficient as a tool, which will also kind of help it in a way on the sustainability route. But what is cool is that we've been talking about performance earlier, that many of the security tools can hamper performance quite a bit, and that kind of also this collaboration makes it quite visible that even though Falco is quite mature as the tool in the CNCF landscape, you're still like looking into performance and finding ways to be more resource efficient. And I personally find it great that there is focus on that. And I think all the tools should keep looking into the ways to improve that resource usage efficiency.
One thing we can also take away from what Nigel said before was, for anybody that wants to get an idea on the security landscape in today's Kubernetes world, you can simply write a report with just one question, and you'll get all the answers that you need there. And that question is, how many of your pods are running with the default service count? And if you get the twinkle in everybody's eye, that'll give you enough information. Boy. All right, cool. So wrapping up here, Nigel, I'd love to give you the opportunity to plug away anything you'd like.
Yeah, absolutely. So even just a take-home message around Falco, the project's always evolving. When we think about where it started off and its roots from just system call introspection, it's moved a long way on from that. So this idea of adding on these third-party plugins, the ability to handle event streams, authenticated event streams from third parties is a huge addition. So taking events from, say, for instance, Kubernetes audit log itself, as opposed to just the host system calls, or from AWS CloudTrail, allows for some really compelling stories that you can put together. So one of them is through a concept known as data enrichment that we do in Falco. So I'll give an example. If, for instance, you have a Kubernetes workload and it shuts down, and you really want to know why that happened, or maybe even my whole cluster shut down, and I want to know why. So if you only had system call introspection, you might see that a pod or something, your processes have crashed. With Kubernetes audit log, you would get events from the actual Kubernetes API itself to tell you something on the lines that the pod was shut down. But having the context from CloudTrail audit log, you can say EKS service was shut down, and having that context is really important for root cause analysis. Being able to correlate context across Kubernetes cloud and the workload and containers is incredible. It means in the metadata output of the event, you would see something like this process in this container on this host in this specific cluster running in this cloud environment has a problem. And imagine the alternative. If you said, like, if we're only looking at a process level, great, where's that process running? How can I do it? And containers, if we're talking about container IDs, they're not long lived. So those change all the time. Same with the IP address, they're ephemeral by nature. So audit logs from Kubernetes certainly helps to give something more concrete. This pod, this deployment in this cluster, that will help us go somewhere. But if I'm managing hundreds of clusters, I want to know, okay, well, what region and what AWS zone is that running? Again, it's the complexity of the cloud and scalability. So that's a huge take-home message. But also, as the project evolves, we've gone from being traditionally a monitoring technology. Some people might even categorize as an IDS, an intrusion detection system. But we've evolved to have now monitoring through Falco Sidekick. So we now expose a lovely UI that can show you all your events and event correlation and mapping. But also that Falco Sidekick can be used for forwarding response actions to things like function as a service so that you can actually take action on something malicious you saw in your environment. And then going a step further, if I'm speaking a little bit too early on it, but we're planning on adding an additional response engine directly within Falco called Talon. And now you can do, for instance, interact with Kubernetes primitives. So if you see, for instance, a cryptominer running in a pod, well, you can gracefully just terminate that pod. Or, for instance, enforce that network policy or relabel the workload so that it plays in with all of those DevOps operational or automation actions. So funny, a lot of the things we're talking about today will sort of be addressed in either today through Falco Sidekick and its automation actions, but even through the direct response engine that's we're planning and implementing in Falco. So it's an exciting time to watch the project evolve. And yeah, I'm hoping to show it to people soon.
Awesome. Very cool. Well, thank you so much for coming on. Really do appreciate it. And for everybody that's listening, if you want to dive into any more conversation around this stuff, if you go to the Packet Pushers community Slack channel, we do have a Slack channel dedicated to this podcast. So if you want to hop in, ask questions, get links, etc., definitely let us know. Thank you so much, Nigel. Appreciate you coming on, and thank you everybody for listening.